All right, so this is the second assignment. So in the first assignment, you were tasked with coming up with a UML diagram, class diagram. Here instead, we start from a UML class diagram. We give you a UML class diagram, and we ask you to convert it into a relational model. Right? We ask you that given these various classes and these various associations and constraints between the different classes, we ask you to convert this into a relational model. So all different tables, mappings, and whatnot. And notice that we have tried to capture all sorts of different little things here that we'll ask you to do some of the challenges here. So notice that we have several one-to-many. We have inheritance. We have aggregation. We have composition, right? We have a mapping tables, right? So we have all sorts of different things here that certainly will give you a lot to do for the next couple of weeks. And also today we'll talk about being able to implement inheritance, and we'll talk about different ways of implementing it. Right? For instance, I believe in the assignment I asked you to implement this inheritance relationship one way. But this other inheritance relationship, I ask you to implement it in a different way, okay? And each one has its own quirks, right? Its own reasons of being. So let's talk about a little bit about the narrative, right? So this is a class diagram that describes a somewhat of a content management system that has certain folks that can access the system. You have just a regular user, and you have a developer. A developer, the developer of the content management system, right? That can create websites, can create pages. So this might be a designer, right? That has access of being able to edit a web page, a website, whereas a regular user cannot modify. They can only consume. It's only read only for them, right? So this might be like Weebly or Wix or any of these many content management applications out there, right? That allows you to build a website, right? By dragging and dropping and whatnot. So these are both persons, and they both have many phones, many addresses. So here the one-to-many is implied, right? That a person can have many addresses, a person can have many phones. But a person has a developer key, whereas a user has a user agreement, whether they've agreed to the legal to legalities of the website, of using this application. Now, a developer can develop many websites, right? So presumably they might log in and see that they're working on many websites, right? So they're working for different clients. They might have different websites that they're building. So there's a one-to-many websites, right? And each website might have a name, right? Might have a high-level description, when it was created, how many visits, folks are visiting this website. It has a counter, how many visits has there been, and notice that there's it's an aggregate here, right? So yes, I can create the website, or I can be associated to the website. Right, but I'm not. It's not a composition, right? If I leave, then the website someone else can take over that website, right? No, not necessarily do we remove the website if there's no developer assigned to them, right? So there's no life cycle dependency between the developer and the website. So it's an aggregation, right? I have a reference to it, but if I remove, it does not cascade to the website. But notice that there is a composition between the website and a page. Right, so a website is made up of many pages, right? The home page, the contact page, the about page, all sorts of different pages. And notice that this is a composition, right? If I remove the website, the pages are also removed, right? It might make no sense to keep the page around if there's no website to be associated with, right? I guess here you could argue both ways. You could say, well, there might be a page that is kind of the same page for everybody. Maybe there's a login page, there's a registration page, maybe a profile page that's kind of the same across all websites, and maybe I want to have some way of sharing between them, right? But we're not going that we're not following that, right? Yeah. If you remove the website, the page goes away. Right? And a page can also have a title, kind of description, when it was created, when it was updated, and how many views. Also, a page itself is made up of multiple widgets, right? And these widgets have some certain things that are in common. They all have a name, the width, the height, the class, the CSS class that I can apply to the widget, the style, any text, and an order, because you can have multiple widgets, right? You can rearrange them on the page. You can move them around, right? And so they have a particular order on the page. Now there's many types of widgets. You could drag and drop a YouTube widget, right? And you can then configure the URL from where you got that image, that video, or it could be just a raw HTML widget, right? So it'd be just raw HTML, or it could be a heading, a size, or an image. Okay, notice that these are also all inheritance, right? These are all inherent relationships. In addition to that, we can have developers. Whoever owns the developer, whoever owns the website, they can enlist other developers to facilitate or to help them out on that to work on that website. Okay, and I can associate different privileges or different roles of a particular developer for a particular website. So I might give a developer a read-only a read-only privilege, right? Or I can give them write privileges, or I could do it at a granularity at either at the website level, right? So I can give you write access to a website, and that presumably gives you write access to everything else, right? But I can go even granular and say, no, I can give you privileges on a particular page. What you can do, okay? I can either give you a role. In a role, you can consider role being an encapsulation of multiple privileges, right? So if you have an admin role or a reviewer role, right? If you have different roles, a reviewer or editor or a writer or an admin or an owner, depending, you can consider a role as a collection of privileges, okay? Or I can give you individual privileges, but not to a particular role, right? And a privilege kind of like overrides what a role says, right? So I can give you, I might give you admin role, but I can then go granular and say, well, admin gives you everything. Right? You got powers, you can read, write, you can do everything. You can just create, remove. But I can go granular and say, well, no, not on this particular page. You don't. On this particular page, you don't have the privilege of whatever. Okay, so I can go as granular as I want. All right, that makes sense. Right, that's the narrative of that goes along with this class diagram. Given that, we ask you to do a couple of things. So one of the first things that I ask you to do is to create a schema. Right, so in using SQL Server to create a schema, and the name of the schema needs to be homework 2, last name, first name, summer 2018. Okay. I need you to have that same schema because the TAs are going to have a similar schema. So when they're going to grade you, right, they want to be able to compare what they have against what you're going to do. Where last name and first name is your last name and your first name. Okay. So that's 0 points. That's a given. All right. So for 5 points, I ask you to start creating tables for each one of these, right? So to create a person table and a phone table, an address table, all these tables, right? So for 5 points, ask you to create the users who are going to use this, right? So it's going to be a person, developer, user, and says notice that here there's generalization implementation here. So we're saying that user and developer are derived classes from person, right? So these are specializations of a person, or the other way around. Person is a generalization of these two, right? Either way, depending how you look at it. So here we're asking you to any constraints that you might have, like for instance, where you have a one-to-many or person or whatnot, if it has references or constraints, like to follow a naming convention. Right? And the naming convention is that, say it's a naming convention constraint. Okay, the foreign keys. The name that we want is that if you have a subclass, which is maybe user and developer or subclasses, and then superclass might be a person, right? Then name it something like a developer person generalization or a user person generalization. Okay, so name your foreign keys using this naming convention. Where subclass and superclass are the subclasses and superclass in the diagram. For instance, if a person is a superclass and faculty is a subclass of person, then the foreign key constraint would be called faculty person generalization. Okay. All right, so that asks you to implement those tables. Using a separate. Okay, notice that this says implement generalization using a separate table for each class. So there will be 3 classes, right? There will be a person table, there will be a user table, and a developer table. Yes. And the way that we're going to implement it is that person is going to have a primary key, and each one of these is going to have a primary key that is also a foreign key, right? That references the primary key of person. Okay, that's a multi-table or a table per class implementation strategy, and that's not the only strategy. Right? There's multiple strategies. There's like 3 or 4 different strategies. Okay? That's the most basic one. You're using a normalized implementation where each class gets a table, right? I think it's the most intuitive implementation, but there's others. We'll talk about a couple other ways to implement it. All right, so that's those first 3. The next will be create tables for website, page, widget, heading, all these, right? Using generalization, using the single table strategy. Right? Notice that these classes, widget, image, YouTube, heading, and HTML, also are in an inheritance relationship. See that? But here we're asking you not to use the multi-table implementation. Instead, we're asking you to use a single table, right? Which is also referred to as the denormalized implementation. This one, I'm asking you to do the normalized implementation. This one, I'm asking you to use the denormalized implementation, right? In that implementation, instead of having 5 different tables, okay, instead you would have just one table, one widget table, right? And this widget table would grab all the fields from all the other tables. Right? So this one big table would also include not only the widget features, right? It would also include the YouTube attributes, the image attributes, the HTML attributes, and the heading attributes. Would all live in the same table. Okay? All right? Plus one additional attribute, a type attribute that tells me whether this widget is actually a YouTube widget or image widget, an HTML widget, or headings widget. Right? It would be like a enumerated data type that tells me what am I. Right? So that when you look at a record, you know to interpret it either as one widget or a different type of widget or a different type of widget, right? So only a subset of those fields will make sense. The other fields will be ignored, right? They will be null. They will be null, right? So for instance, for the widget, all widgets will have this data. But if this is a YouTube widget, then I will have values for URL, shareable, and expandable. But I won't have values for src, HTML, or size. Those will be null because I am not a heading table. I'm not a heading widget. I'm not an HTML widget. I'm not an image widget. I'm a YouTube widget. Right? So I don't have values for the other 3. Right? I only have values for this, but in this table. That makes sense? So that's a denormalized implementation, right? Where all other subclasses, right, are squished into the superclass. Yes? Yes.
Question on that. Sorry, you might have said this, but so if I'm a YouTube widget and we have shareable and expendable on our table, would those features be null if in image as well as heading in HTML?
So it's one single table. Sorry. So it would be one single table, the widget table, right? And we'll have fields. Some fields will be for the YouTube. Some fields will be for the image. Some fields will be for another one and another one. Yes. Plus an additional one. Plus an additional one. A type. Right, a type. And if this is a YouTube, then I'll have values for these. But all the other ones will be null. Okay? If this is an image, then I'll have values for this. But all this will be null. And this will be null. Okay? It's denormalized because usually you want to break out all these into individual tables, right? Typically, denormalizing is a no-no, right? But in this case, right, the big problem in generalization, as we'll talk about a little later, is that when it's shallow like this, it's not a big problem, right? But in a class diagram, it's very common to have multiple hierarchies of inheritance, right? Where you have a table, a class inheriting from another class, from another class, from another class. So it's a very deep inheritance hierarchy, yes? And to reconstruct a record, say I want to reconstruct the YouTube widget, right? I'm going to have, if I'm using this strategy, the normalized strategy, I need to join the YouTube table with the widget table, yes? And joins are expensive, right? And if it's shallow like this, it's not a big deal, right? But if you have an inheritance that's very, very deep, you need to join all the tables, right, in the inheritance tree. And that's very, very expensive. Okay, it increments exponentially. The time complexity increases exponentially, right? To search one table, it's linear. To search a join between two tables is quadratic. To join 3 tables is cubic. Right? To join 4 tables is to the 4. So it increases exponentially the amount of time that it would take you to join all these tables. Right? So usually, when we do the mapping between class diagram generalization, we implement it using the single table implementation, the denormalized implementation, because then you're not joining anything, right? You're trading time for space. You have a lot of empty space, right? You have a lot of nulls everywhere, right? Where only a subset of the data makes sense, right? And the rest of the data is null. Usually you don't want to see that in a relational database, okay? But here's a very good reason to sometimes do it, okay? And you have that strategy. There's another strategy, the third strategy, we'll talk a little bit later, where instead of denormalizing up to the parent, you denormalize down to the children, okay? And we'll talk about that a little later, right? So that one is kind of the best of both worlds. You're normalizing, you have everything in their own table, but then you don't have to join them because all the data lives in the leaves, which is pretty cool. Anyway, we'll talk about that a little later. Okay, so it's asking you to do those two strategies, right? One, the normalized implementation, and the other one, the denormalized implementation. All right, so next tables, address and phones for the one-to-many relationship. Those are trivial ones. These are just foreign keys back to the parent. And create tables for website pages, roles, and enumerators. So these are actually there are multiple. These are many-to-many, right? Where you have these are like association classes, right? That says, hey, that person over there has a privilege, this particular privilege on that artifact over there. Right, so it's an association class. Once you have the schema all set, we ask you to exercise lots of inserts and selects and updates and deletes in SQL. We ask you to, given this data, Alice, Bob, Charlie, Dan, Ed, right, to insert these folks into into either the developer table or the user table. Right. Notice that even though they're being inserted into the developer and user, notice that some of these things are going to go into the person table, and these things are going to go into the developer table, and some things are going to be into the user table. So there's 3 tables happening here, yes? Right? They all involve updating the person table, but some of them involve updating the user table, and some of them involve updating the developer table, right? To implement the normalized strategy, yes? All right, so 4 points for that. And then we ask you to insert the following websites. So you need to insert Facebook, Twitter, Wikipedia, CNN, CNET, Gizmodo. Just some description. So these are the owners, right? So these are the editors, these are the admin, and these are the visits. So these are kind of roles. So Alice has an owner role on Facebook. Bob has an editor role on Facebook, and Charlie has an admin role on Facebook. Yes, and they all mix and match, right? It's the same. How many? The same 5 people over and over, right? Obviously, you'll need to keep track of the IDs of these users, right? When they're getting inserted, right? You need to keep track of those IDs because then you're going to need them again over here. Yes. Then create the following pages for the following websites. So you have home, about, contact, preferences, and profile. These are 5 different pages in the following websites: CNET, Gizmodo, Wikipedia, blah blah blah. These are the websites you created earlier, and these are the roles of these users at these pages. Remember, you can set a role at the website level, and you can also set a role at the page level. Yes. Right. All right. Then once you have a couple of pages, we're going to add a couple of widgets to those pages. Right. You're going to add a heading widget, an HTML widget, another heading widget, HTML image, a YouTube widget into the pages. Which page? Okay. Home, about, contact, and preferences. Which are the websites that are listed up here. These are the pages that we're referring to. Yes. And finally, insert the following addresses and following phones for these users, of which some of them are the ones that are in bold. I believe they are the primary address and primary phone. So I'm guessing in the address and the phone, notice that we have booleans. See that? Primary boolean and primary boolean. So some of them will be true, some of them will be false. Yes? What else? All right, once you have that data inserted, another 20 points for selecting data, retrieving data, querying data. Some of them are very, very easy. Give me all the developers. That's easy. Now retrieve developers with the following ID, where the ID is equal to 34. Charlie. How did I come up with 34? Oh, I give you IDs. Okay, I'm sorry. I do give you IDs. All right, so yes, excellent. So since you know the IDs, right, you can reuse these IDs, right? Instead of Alice, Bob, Charlie, you can use the IDs that I provide you here. Okay. Okay. Yes. So retrieve a developer with ID equal to 34. So it must be Charlie. Retrieve all developers who have a role in Twitter other than the owner. So retrieve everyone who's not an owner. Okay. Retrieve all developers who are page reviewers of pages with less than 300,000 visits. Okay. So again, these are a whole bunch of joins, with a whole bunch of where clauses and navigating from one to other. So just practicing joins. Retrieve the writer developer who added a heading widget to CNET's homepage, Charlie. So this is, I believe these are right. There might be one or two that are wrong. I don't know. You might want to verify that. Retrieve website. Retrieve the website with the least number of visits. Retrieve the name of the website whose ID is 678. Retrieve all websites with videos reviewed by Bob. So a whole bunch of these, right? Retrieve pages, widgets. And then, so those are all select statements, queries. And the other ones are updates and deletes. So this one says, update the developer, update Charlie's primary phone number to 334455. Update the widget, update the relative order of widget on the page so that its new order is 3. Note that the other widgets need to be updated as well. So if you move a widget on the page, right, has an order. These are relative orders with other widgets, right, that appear on the page. If you drag them, right, you move them around, all the orders of the other widgets need to change. Yes? So you need to update that as well. All right, so a whole bunch of swap roles between Charlie and Bob. Append CNET to the beginning of CNET's page title. And finally, deleting a whole bunch, delete Alice's primary address, and whatnot. Okay? Right, so the result of this should be one single SQL file, right, with all the creation of the schema, creation of the tables, doing all the inserts, doing all the selects, doing all the updates, doing all the deletes. Okay? All right? Awesome.